Hello everybody, I'm Jonathan Lewis, and I don't know if you heard me speak on the last occasion that Grant and I had a discussion, but at that time there were problems with my mic. I hope those problems have gone away. I discovered after the event was over that my microphone was actually broken and my laptop was picking up the sound, so naturally every time I moved my head the sound faded. I've now got a new headset. I'm ready and armed to talk about temporary tables. I'm the Oracle specialist of the two here. I've got 24 years of experience of using the Oracle database, a few more years of IT in general, and I've written a few books about Oracle to help people along the way.
My name is Grant Fritchey. I work for Redgate Software. I've been a developer and a DBA for longer than I care to admit. I've written several books on SQL Server, or parts of books, and I'm a real big nerd and really enjoy playing with the tools that SQL Server offers. So that's about all I want to say. Let's go and have fun, talk about temp tables.
Okay, well, shall I begin with a quick description of what we mean by a temporary table in Oracle? Would that be the best move?
I think so.
Yeah.
Right.
Okay, so Oracle and temporary tables. If you talk about temporary tables in Oracle, there really is only one thing that you ought to mean. Technically, Oracle talks about this as the Global Temporary Table, or GTT. And the Global Temporary Table is, well, as Dave Enser once said, Dave Enser, by the way, is a name that perhaps will be familiar to the older Oracle people. As Dave Enser once said of Global Temporary Tables, Oracle calls them that because they're local and permanent. The Global Temporary Table is, in a sense, permanent. The Global Temporary Table is a structure which you can define just once in principle at the start of creating your application. There is a data definition, a description of the table stored in the data dictionary, but it's given the label of Global Temporary Table. The definition is there permanently, it's fixed. Similarly, when we talk about global temporary tables, you can use these things. They're global in that anyone can actually use this thing which is called the Global Temporary Table, this definition that you've created. However, Dave Enser's comment about them being local, whenever you start to use this definition of a Global Temporary Table, Oracle will create a completely local, totally private version of that table in the temporary table space, the equivalent to the SQL Server temporary database. Whatever you do with that table, it's a totally private copy. The advantages then to Oracle of this global temporary table are simply that being in the temporary table space, some of the maintenance overheads which you normally expect to see as you manipulate data, some of those overheads of read consistency, undo and redo and so forth simply do not need to be applied. So it's slightly cheaper in most occasions to manipulate these global temporary tables than it is ordinary tables. There's also a particularly special side effect of the global temporary tables being private, of course, which is if people are sharing a table, a genuine ordinary table, as some sort of scratchpad area, Oracle runs the read consistency issue and says if you insert some scratchpad data into this table and another user inserts scratchpad, we have to do lots of extra work when you query your data because the other set of data has to be hidden. So there's a reduction in conflict, a reduction in contention, and the overheads relating to read consistency. A couple of little special points then about global temporary tables. You can actually define them to have two different types of behavior. When you create the definition, the create global temporary table statement, you either create it as on commit preserve rows or on commit delete rows. Now, the default option is on commit delete rows, which means when you put data into your private copy, at any time if you say commit, this data simply vanishes. And of course, compared to historic using of ordinary tables to hold data temporarily, to get rid of data from an ordinary table, you'd either have to run a truncate command or a delete command. And if you were sharing this scratchpad area with someone else, you'd have to do a delete command. and the cost, the overheads of actually deleting all your data could be really quite expensive. So being able simply to say commit and finding the data disappearing is a significant benefit. Of course, sometimes you want to be able to say commit, do something with the data, say commit again and carry on. In this case, we have the on commit preserve rows. Essentially, with those types of table, the data persists across the commit. If you want to get rid of the data, you then actually have to say truncate the table. And again, even in this case, truncate is just a tiny bit special compared to ordinary tables. Truncate is normally considered to be DDL, data definition language, and it has all sorts of side effects in terms of invalidating existing cursors. Apart from a bug in earlier versions of Oracle, the truncate of a global temporary table does not invalidate all the SQL that has been using a private copy of that global temporary table. It only invalidates the SQL that you personally have been using. So there's a little benefit there as well. That really more or less sums up, just as a thumbnail sketch, what we mean by a temporary table in Oracle. There are other occurrences, and they're all internal occurrences of something very, very similar to global temporary tables, but I'll bring those into the conversation that Grant and I are likely to have as we go along. But at that point, I think it's probably a good idea to hand over to Grant to give a similar sort of sketch of what we mean by temporary tables in SQL Server. So Grant, over to you.
Thanks, Jonathan. Actually, that was pretty interesting. I didn't know most of that stuff, so I'm learning. This is great. All right, temporary tables in SQL Server. We have a lot of temporary tables in SQL Server, and unfortunately, there's a lot of myths built up around them. Let me give you a quick run through what they are, how they work, and maybe point out a couple of little mistakes that people commonly make. First off, all temporary tables in SQL Server are created in and around our TempDB, as you already mentioned, and that's all temporary tables. Now, they fall into three basic areas. There is the global temporary table, regular temporary table, and then a table variable. I'm going to spend a little bit of time talking about a table variable because they are different. The main difference on the global and the regular temporary table is just a question of scope. Most of our temporary tables, when they're created, you basically build a table and define it as a pound table name. That actually creates a temporary table for your session, and it is session limited. So while you're connected up, as long as you can send in multiple batches that refer to that table, but while you're connected, that session, that table is maintained within TempDB by SQL Server. The global temporary table is a little different, and that's as long as any session remains connected that is referring to that temporary table, to the global temporary table, then that temporary table will remain active. A few things about the temporary tables, they have statistics. So when you insert data into them, new statistics are created. This has implications. It means that the optimizer can use these things within queries and come up with good execution plans based on these statistics. But conversely, it also means as you insert data into them, queries that reference these temporary tables must be recompiled as data changes, and that can lead to performance issues or just some resource issues as that stuff occurs. So that's one bit. You can create indexes on them, you can create constraints on them, and just more or less refer to them as a table. And then you can, you were mentioning truncate before, you can truncate these tables or delete from them. Deleting is obviously going to be a more costly operation, but you can truncate them, but you don't have to. I've seen tests, and I've tested it myself, and unfortunately the tests kind of run both ways. Depending on the amount of data, this processor, the amount of memory, all kinds of other stuff, truncating can be faster than simply ignoring the temporary table, finishing your session, and letting SQL Server clean it up. Or it can be slower than finishing your session and letting SQL Server clean it up. So it kind of depends. You may have to do some testing to determine in your situation which one of those is going to be quicker. but by and large, that kind of gives you an overview of how temporary tables work. Now we have this other construct called table variables. Now table variables are declared just like a variable, except you define a table. The main primary difference between temporary table and table variables is the lack of statistics. Now table variables are created in TempDB just like temporary tables. This means that they write to memory and disk just like temporary tables. For a long time there's been this myth out there that table variables are memory only, and that is patently false, just 100% wrong. The allocations are the same as temporary tables. They go into TempDB, which means memory and disk, and they are more or less treated roughly the same in that regard. The primary difference is that there are no statistics. This means as you add data to a table variable, you don't have to worry about recompiles. However, then you run into the other issue. Because there are no statistics, the optimizer is always going to assume that these things have one row, regardless of how many rows you put in. You put in 1,000 rows, it's going to assume one row. You put in 10 rows, it assumes one row. And that's going to make a big difference in the execution plans that get generated, because those are completely dependent upon you having good statistics to get a good execution plan. And so in this situation, you can get some pretty heinously bad execution plans. Temporary table variables cannot have indexes placed on them. They can have constraints put on them, but don't get confused that if you put say a primary key constraint, that you then get statistics. You do not. Even though it does allow you to put in a primary key constraint, it just acts as a constraint. It does not act as an actual index because there are no statistics. These things are very different than the others. Where global temporary tables were while any session is connected that referenced it, they remain in memory and on disk. And table variables are while your session, temporary tables are while your session is connected, they remain. Table variables are within a single batch. So any given batch can reference the table variable, but once that batch completes, you put a go statement in there, or in any other way terminate the batch, that table variable is no longer referenced, and it will go away and get cleaned up by SQL Server, by the the memory allocation methods. We're not going to get into that detail, but let's see. That's about it for temporary tables within SQL Server, as at least an overview.
Right, well thanks for that, Grant. There's all sorts of interesting things come out there. And I have to say, I'm always fascinated with the way in which we get together and we talk about a few things, and you can see some dramatic similarities between Oracle and SQL, and just as you think you understand what's going on, you realize there are also some dramatic differences. And the way the same terminology almost can introduce completely different ideas is quite staggering. So it's not really surprising that sometimes you get people having ferocious arguments about whether SQL Server's got a better way of doing this or whether you should do it like that in Oracle and so forth.
Right.
Yeah. Yes, I mean there's all sorts of sort of points you made there where I thought, oh yeah, we could talk about that for ages. And interestingly, your comment there about table variables, and of course in Oracle, if you start talking about variables, you almost automatically switch into a PL/SQL environment, and I think the sort of Oracle and SQL Server are very different in that Oracle, you tend to think in terms of, I'm either running a series of SQL statements and the statements can't really talk to each other, or I've written some PL/SQL, the sort of roughly equivalent to T-SQL, and that's how you get one statement to populate variables which can be used in another statement. It's not a 100% description like that, but true. But it's that sort of feeling to it. Whereas, of course, I think with SQL, yeah.
Can I ask a question about it?
Yeah, sure.
Where are global temporary tables used in Oracle? I mean, what is their primary? I mean, your overview was good. I kind of left mine where mine are used out on purpose. But
Yeah.
I'm just curious, where are they used in Oracle?
Well, the explicitly declared type of global temporary tables come in, of course, in these sorts of circumstances where someone runs a batch script, which is essentially a sequence of SQL statements. There might be a few little decorative bits about it, of course, around the edges, or perhaps inside one large block of PL SQL, which is just used to gently wrap and enhance a sequence of SQL statements. So you might get some sort of batch process which says, I'll do something a bit complicated and I want a result set and I will therefore need to store it somewhere, so I'll put it in a global temporary table. And then following on from that, I might run reports, I might run basically SQL statements against that global temporary table, getting results out from it, analyzed, summarized, and reported in several different ways across several different dimensions. So that rather than saying, report number 1, do this complicated statement, but only report columns 1 to 4 in this order, breaking on X, Y, Z. Now, part number 2 is more or less the same statement, but it's a different set of columns in a different order and so forth. You do the complicated bit once, do the expensive bit once, and then you've got the results available to reuse.
Well, I mean, that's actually the same thing you would use it for in SQL Server. It's just, I guess that differentiation between SQL in Oracle and PL SQL in Oracle, as opposed to as far as, I mean, I've never heard anyone refer to it separately, but it's all T-SQL to us in SQL Server land. So,
yes. I mean, I think it had struck me when I was experimenting a little with SQL Server a couple of years ago that there was this astonishing difference that you could write what appeared to be a sort of multi-step little program which mixed what I would call SQL statements with other bits of code as a continuous program, and in your, I think your output screen, the little window of result sets, you could manage to get some very complex shapes of results because you could simply say to SQL Server, there's my program, just do it. Whereas in Oracle, it's very, very much either here's an SQL statement, what's the result? Here's an SQL statement, what's the result? Or you wrap some sort of language, and the sort of closest language to the database is PL SQL. You wrap that language, but then part of your language, part of your code actually has to deal with outputting the results. All that sort of handly output seems to be more or less embedded in the interface that you get straight into SQL Server.
wow, that's interesting. Now, you guys don't have, there's not like a differentiation between table variables and temporary tables then? There's not like two different constructs that
well, yeah,
similar but different?
Well, yes, indeed, there are, because you have the concept of the abstract data type. You can construct new data types in Oracle, and you can construct a type which is a complex type, a multi-value type, a non-scalar type. So you could quite happily construct a type which you might call employee line. So we say an employee line consists of a record. It's a record which is a number followed by a character string which will be the last name, a character string which will be the first name, and a date which will be the date of joining. And you can construct a data type of that sort. And you can construct that as a type which is defined within the database, or you can construct it in PL SQL as a type which can then be used in a PL SQL program, and those two types aren't exactly the same sort of thing depending on their context. Once you've got a type of that thing, you can then declare a table type. You can just say employee lists is of type table of employee lines. Right? So you end up with, again, you can either have this as just something which you've created sort of loosely in a PL SQL program, and it'll be a type which will disappear when that PL SQL block basically ends, or you can construct these as types, abstract data types that can be used in a database, can even be stored as columns in a table in a more traditional table in the database.
Right.
And then when you come to the table variable, you can actually say within PL SQL, this PL SQL variable is of type X, which could be a database table type, or it could be of a PL SQL table type. So the idea of a memory variable which contains something which looks like the contents of a traditional table is available in Oracle. Right?
Okay. Well, now, if
yeah.
if you have a transaction wrapped around that,
yeah.
how does it behave within the transaction? Does it roll back and all the rest of that stuff?
Now, when you're talking about table variables, you're not talking about something which is going to contain data that gets written to the database. So the whole transaction processing bit is irrelevant. It really is, when you create a variable of type table, it is simply a piece of information which is in memory.
Okay. Well, that's actually, well, I mean, while ours aren't strictly in memory because it definitely gets written out to disk too.
Oh, right, yeah, yeah.
It's actually the same. A table variable within ours is not part of a transaction. It's not rolled back as part of a transaction, which again has to do with the fact that there are no statistics for it. But that's pretty cool.
Yeah. No, I have to say that by and large, if someone said something about a table variable, they would probably be thinking about the PL SQL type. The table types that you can declare for the database, the abstract data types, don't get used terribly much by the average application in the Oracle world. But the PL SQL table types, the sorts of things people do with them sometimes is have a program which constructs a list of interesting pieces of data and will then temporarily insert them into a PL SQL table type as a way of accumulating them. And then there are various games you can play with table types, because from Oracle's perspective, a table variable can be treated exactly like a genuine real table as far as an SQL statement is concerned, in just the way the SQL Server table types can be. And in fact, more as a refinement on that, if you create a function that returns a record, in other words, something roughly equivalent to a single row in a table, if you create a PL SQL function that returns a record, you can actually cast that function in a way that makes the output from that function appear to be a table. So you can write a function which says, and they're called pipeline functions in this context, you can write a function which says, do a bit of work, construct a row, pipe it, do some more work, construct another row, pipe it, and keep on going. And then in your SQL, a simple SQL statement, you can say select from, and then table brackets, and it's a table cast operation, table brackets, here's the function name with some inputs for it, and your SQL will call the function, but it will treat it in such a way that it behaves almost exactly as if it were just an ordinary table. Right? And interestingly, of course, you made the comment about statistics. In that particular circumstance, the optimizer has no idea how much data will be produced by that call of a function. So, of course, you're running a statement for which there are no statistics, and if you include one of these table cast operations inside a more complex SQL statement, the optimizer just hasn't got an idea of how much data overall is going to appear, because perhaps this driving table operator, this function, is going to be the thing which drives the rest of the query to run.
Right. We actually have the same thing. It's called a multi-statement table valued function, because we have an inline an inline function that it's just more or less think of it like a parameterized view. It's resolved in a similar fashion. But the multi-statement table valued function outputs to a table variable again, yeah, those things are notorious performance pigs. I have a story I like to tell about performance tuning with an 86 table join against multi-statement table valued user-defined functions, but I won't go into it today.
Well, I can guess the end of that one actually, but it is a tricky one. I mean, in many ways they're very nice constructs to be able to use. I've seen various applications which say, if I can produce a table variable in SQL Server terms, if I can produce a table variable which contains the results of some sort of pick list or some way of identifying data, and simply join that onto the rest of my text, which is, a 9-table join with various conditions on it, I can write one SQL statement which always looks exactly the same. I can write the same wrapper around that SQL statement. All I have to do is write some selective code which says, how do you want to pick your rows? And so, of course, you end up with a statement where one user says, oh, I'm just picking one product out of my entire warehouse inventory here, and they run a statement which casts that one product into one row from a table, and then someone else says, well, I'm picking out all the products which we have ever sourced from France from my inventory, and they produce exactly the same table where the table operator generates 10,000 rows, and then both people expect their queries to run really quickly, right? And one of them is bound to be unhappy. Right. But I mean, the strategy is good in terms of simplifying and clarifying the code, but the impact on the optimizer can be baffling, to say the least.
Huh, that's interesting. So it's almost exactly the same issue on our end. I mean, almost exactly. I mean, your language is slightly different, but the issues are almost identical.
Yeah.
I almost feel like it's like when I'm talking to my English brethren, and we're separated by a common language.
Yeah, I think there's a lot of that, and yes, I mean, you get the thing that I might ask someone in SQL Server, how do you do X, and complete bafflement comes back as a response, and yet the SQL Server can do exactly the same thing, but the terminology is sufficiently different that the two people talking don't connect terminology. And of course, it goes the other way around. We say things which sound identical but mean completely different things. So yeah.
Right. Well, now back on the global temp tables. Now, are they abused in any way within Oracle? I mean, is there like a common anti-pattern that you see?
I don't really think so. To a large extent, I don't think many people use them terribly much. So I haven't come across any very bad use. I mean, you get the unlucky use because of optimizer problems. You mentioned that global temporary tables in SQL get their statistics as the data goes in,
right?
Which is really quite a nice touch in many ways. In Oracle, you don't have statistics on global temporary tables, full stop. That's the way it is, at least by default, and up until the latest versions of Oracle. Now, there are various workarounds to that, one of which is that you can say, I can write a program which specifically writes into the data dictionary and puts representative statistics onto the definition of the global temporary table. Right? But you have to be a little cunning and a little cautious when you do that, because everyone then gets the same statistics. Right?
Oh, right.
The other option is that you simply say, well, we'll allow Oracle to do dynamic sampling, which means that when you run your SQL statement the first time, Oracle says, oh, by default, with the dynamic sampling level that's automatically switched on in the latest versions of Oracle, I can see a table which doesn't have any statistics, so I will sample a few blocks from this table to see what the data looks like and estimate the statistics. Right? And that, of course, comes back to your problem of, well, if you have to re-optimize every time you run the query, that's an interesting extra overhead.
Right. Well, and actually, it can re-optimize the queries as it's running, because also our statistics are based on, well, unless you change the setting in SQL Server 2012, the standard is 500 rows changed, or 500 rows plus 20% for any table that's over 500 rows, and that applies to temporary tables too.
Yeah.
So as that data changes, you're going to see recompiles.
Right. Does that mean that any table that you've got, SQL Server is almost always monitoring and collecting and updating statistics as the data changes?
By default, yes, it is.
Oh, right. Oh, that's interesting. You see, one of the big problems with Oracle is deciding when to collect statistics and how large a sample size to collect for statistics. It's not something that just happens continuously and dynamically.
Right. Well, I mean, we could have another talk just on statistics.
Well, I've just made a note to say, oh, our next conversation must be about statistics. Yeah. Yeah, so that's an interesting aspect. I mean, of the whole thing, let alone temporary tables. You see, the thing with temporary tables is, well, since we don't ever sort of dynamically evolve statistics, as you were saying, the first person runs a query, and Oracle says, no stats, dynamic sampling, I will optimize that query. Now, if anyone else runs the same query, Oracle says, oh, that's okay, I've already optimized that one, and uses the same plan and doesn't sample again. Which means if you run a query against the global temporary table, but you've loaded 10 rows into it, and I run what is actually the same query, but I've loaded 10,000 rows into my global temporary my copy of the global temporary table, whichever one of us runs the query first gets the plan that's good for our data. The other one just uses the same plan.
Right. Oh, no, not us. We would, well, I mean, for a regular temporary table, you would get your plan, I would get mine. Yeah. But both would be stored inside of, the TempDB for the data and the plans going to the optimizer. But then for a global temporary table, as we adjust that data in there, we could either, one, be fighting each other, which could be an issue. You'd have to make sure you program that correctly. Or two, as you added data, my queries would recompile.
Right. So I mean, physically, am I right in saying physically when you talk about a global temporary table, you actually only have one physical representation of that table in your TempDB, and everyone is actually sharing the same physical, what I would call data segment. I'm not sure that's the same word in SQL Server.
Yeah, well, yeah, data.
So your
data segment, but yeah, the concept, 100%. We're all sharing the exact same set of data.
Right.
100%.
So I mean that is an interesting, I think, benefit in Oracle, that there is actually total physical isolation between your data set and my data set.
Right. Well, and with the regular temporary table there is as well. Yeah. The whole idea of the global temporary table is a mechanism to effectively share a common set of data that you don't want to create a permanent storage for. Now, frankly, most cases, most of us just go ahead and create permanent storage because it's much easier to manage than trying to manage this temporary object. But I mean, I've seen a couple of reasonably valid uses of the things. It's not very commonly used, I must say.
Yeah. So, sorry, does that mean that if we're using the same global temporary table, you can see my data?
Yeah. Oh, yes.
Oh, right. Okay. Oh, so yeah. The word global means completely different things between Oracle and SQL Server. Right. This is why Dave Ensler, of course, came up with this thing which says global temporary actually means a local permanent. Global temporary tables are completely, the data content is totally localized. Right. So when I say global temporary table, I think I mean what SQL Server calls a regular temporary table.
Right. Exactly.
There is that translational oddity there. Yes.
Well, see, that's where things get interesting. If you create, we can both create temporary tables with exactly the same structures, and then I can modify mine and not modify yours. Yeah. Whereas it sounds like if we create a common global temporary table, I can't really go in there and modify that structure. Is that true?
You're asking that about Oracle, yes?
Yes. Oh, yeah, Oracle, yeah.
Well, if you had the privileges, the DDL privileges on the schema that had created the global temporary table, created the definition, you could change it, unless someone else at that moment in time actually had some data in their private local copy, in their private instantiation. Right. Okay. You see, the principle, the sort of idealized principle in Oracle is that you do the DDL once, you create the structure once, you create the indexes and the constraints on it just once, and that's it. The definition never changes. Right. Okay. And of course there's this sort of generalized principle in Oracle that it's very bad taste to do DDL, create tables, drop tables and so forth, create indexes, drop indexes, in a production system. Right? For a production system, you create the structure of the entire thing once, and from there on, the only thing you do is insert, update, or delete data. Right? No messing about creating or destroying objects. Of course, that's not how it works in real life, but that's a sort of idealized principle. But when it comes to global temporary tables, the idea is that you just create them once, and you don't need ever to change them ever again.
Right. No, SQL Server is just different.
Yeah.
It's definitely a bit more cowboy land over there.
I didn't say that. You said that. Okay.
Oh no, I said it. Yeah. I have no problem with that.
Yes. Okay.
Having been born in Oklahoma, I'm pretty comfortable with cowboys. So.
Oh right. Okay. Right. In the UK, of course, cowboy carries a certain suggestion of undesirable element to it. But, that's just the common language, or rather, the difference in the common language. Yeah. Okay. I did jot down a couple of notes about, yes, I mean, memory usage, of course, is an interesting one because, yes, the global temporary tables, of course, the Oracle global temporary tables are just table-like objects which use the buffer cache, they use data blocks, they use disk space in just the same way as ordinary tables. And this is something that people do actually forget, that if you're writing stuff into a global temporary, it is treated in almost all respects just like any other table. It goes down to disk. But there is the difference between Oracle and SQL Server, the table variables, the whichever way you might create those. If you're using variables, they are PL SQL things which stay in memory, and those definitely don't go down to disk.
No, they're all basically treated more or less like tables in SQL Server. There's no, there are some variations. I mean, again, the whole concept of the statistics is the big one. But by and large, what's stored is, I mean, I haven't seen the internal code personally, but from every discussion I've ever had with anyone, what's stored is the same as what you're storing inside of a table. It's just within the construct of the tempdb, which means if when you clear out, then memory management takes over and clears it out. Or if you reboot the server, tempdb is recreated. So there's nothing ever permanently stored anywhere. But the constructs of storage are the same. But that's also a big part of why SQL Server has such a big problem with temporary tables, is because if people write, frankly, weak code where they're doing too much in the temporary space, that tends to bottleneck within tempdb, and that causes issues.
Yeah. It's yes, interesting you just brought up that point, because I was just planning to ask you. You said to me, do I see people abusing global temporary tables? I was just about to bounce back to you. Well, are there ways in which you see common patterns of abuse with either global or regular or table variables in SQL Server? What are the big mistakes or the common mistakes which matter?
Well, with temporary tables, the big mistake is just that people load it up with tons and tons and tons of data, and then are like shocked that when they connect up hundreds of people to it and they're pumping all this data in, that they have major bottlenecks in that area. With table variables, it is largely a question of ignorance. People don't realize there are no statistics, so they'll put 10,000 rows into it or more, and then run a query against it, and they can't understand why the optimizer is so, why the query itself is so slow. Or worse yet, they start joining them and doing other stuff with them. And also the whole thing with, like, well, they only exist in memory, so I don't have to worry about it. That also causes problems. It's mainly a question of not so much of abuse through misuse as abuse through ignorance more than anything.
Yeah. Yes.
Unfortunately.
Does SQL Server give you any way to work around, well, approximately perhaps, the no statistics on table variables? Oracle, for example, has a not very well documented cardinality hint. So you can actually say something like, here's this query here, it's got a temporary table in it, or a table cast operator sitting in it. This table cast is going to give you 250 rows. and there is actually a hint which says cardinality, this object, this much data.
Right. Not that you could get into with SQL Server, not in a meaningful way, no. I mean, there are, you could force some join hints if you want, but those aren't necessarily going to be helpful. They could be. I mean, with some experimentation, you could probably, depending on your situation, find, you know, a particular join works better with that table variable. But there's
Right.
no real way to control the cardinality or make any suggestions to the optimizer in that regard.
Right.
You guys, frankly, do have a few more knobs to tweak in that, you know, in that type of thing than we do.
Yeah. But presumably, if you have some sort of knowledge about what constitutes a good execution plan, you could essentially just construct through a set of hints something which says to SQL Server, okay, I've given you this text, but just don't work it out, just do this. You can tell it join orders and join. I'll just jot down hints as a possible future discussion as well, shall I? Do you have that option?
Oh, my dog.
I'm sorry?
Sorry, my dog's making noise. I don't know if you guys can hear it or not.
Yes, yeah, just a little bit in the background there, yes.
Okay, as long as it's only a little bit. Well, we're almost up for time. Are there any questions from the audience? I can't see any.
Well, at the moment, I've just popped up on my screen that a quick poll has jumped up to see which of the products or whether there's even a competing product that some of the audience uses.
Hi, Jonathan and Grant. I've got a different mic. How do I sound on this mic?
You sound great.
Sounds almost human.
Fantastic. So thank you both again for taking part in the discussion, and thank you to everybody that has hung on in there and listened to it, particularly from the bad start. I can only apologise for the mic that was using. We do have a number of questions that have come in, so I'm going to put these to Jonathan and Grant now. I hope you've enjoyed the discussion as much as I had. Unfortunately, due to the sound at the beginning, I wasn't able to explain clearly how this webinar works compared to other webinars that we run, which tend to follow a presentation and show some screens or maybe some live demos. The purpose of these particular webinars, this webinar series, is a live discussion between two different experts, an Oracle expert and a SQL Server expert. We will be running further discussions like this in the future as well. So I hope you've enjoyed a slightly different thing and something that can't really be supported with slides due to the live nature and the free-flowing discussion. Okay, so we've got some questions here.
Okay, James, a quick point there. I think you might be a bit too close to your mic because I'm getting the sort of explosion on the P's and a few of the other letters there as you're speaking, which is blurring the mic.
Thanks, Jonathan. So got a clearer mic, but maybe still not good enough. So needs to be a bit of testing on that. Okay, so let's go into the questions that we've had so far. So we've had quite a few questions. Thank you to everybody that has filled in the poll. So I'm going to go through these questions now. If you haven't had a chance to fill in the poll, please do so. It's quite interesting to know the split of the platforms that people are using. Okay. Okay, so we have a quick question here for Grant. This is I hope it's got quite a short answer, but it's from Jack Walton. Thank you, Jack. Do temporary tables in SQL Server work in the same way in SQL Azure? If not, how extensive are the differences?
They work roughly the same way. I don't believe you have global temporary tables in SQL Azure.
Thanks, Grant.
Sure.
Okay, next question here for Jonathan. This is from Alexandra Tokarev. Thank you, Alexander. I've got quite a long question. There's a number of parts, so I'll try and explain through it. So okay, so this one here. So what's the internal difference in terms of Oracle processing between delete and truncate for global temporary tables, except of implicit commit?
Right, well, a delete has to delete every single row in the table. That means because of the read consistency model that Oracle uses and still uses, even though global temporary tables are totally private and you might think you don't have to be read consistent, the read consistency model says if I delete something, I have to keep an old version of it in the undo table space, a special area for keeping history for a while. So deleting row by row, you change the table once for each row in the table. You record the thing that you have deleted in the undo table space, and then you have the logging mechanism, the redo logging, which says I have to describe both those changes and write them into the redo log. So you can generate a huge amount of activity simply by saying delete everything. When you say truncate, depending exactly how you've created the global temporary table, there are a couple of slight differences, but essentially you're saying to Oracle, the data doesn't exist, there's no way you could possibly change your mind about this and get the data back. In one case, it's simply Oracle saying, the table, you thought it was 7,000 blocks long and there was these blocks from the database belong to your table. I've just changed the segment header on the table to say there is no table, there is only a segment header which says the table is empty. It takes just a couple of hundred bytes or so of this undo and redo stuff in order to make that change, and your table disappears virtually instantly.
Great. Thank you, Jonathan. I have another question here from Ian Haskam, and he's asking, how do global temporary tables differ using the with clause with materialized hint? Does that make sense?
Right. Okay, yeah, that certainly makes sense. And there's just so much one could say about the sort of internal hidden global temporary tables that Oracle generates. There's the with clause. I think in SQL Server, you'd call, Grant, you correct me on this, you might talk about common table expressions. Is that the way you talk
Yes.
about? Yeah, okay, common table expressions. For a common table expression with, and then here's a subquery, perhaps several of them aliased one after the other, and then you hit the main select statement. Oracle has the option of simply copying your text in line to optimize the statement, or it will actually create a results set and say this is now a temporary table, it's equivalent to a global temporary table. Any references to this, I will visit the global temporary table. Essentially, the only difference between a global temporary table that's the materialized version of a common table expression, a with subquery, is that the definition of that object is kept in memory. So Oracle does the select, which generates the data. It will actually write that data directly down to the temporary table space. It will write it to disk. And then when you hit the main SQL statement, Oracle will read that data back into the standard buffer cache as part of the processing of that query.
Thank you, Jonathan. I have another question from you, for you actually, from Russ Kochever. I hope I pronounced that correctly. Thank you, Russ. What index strategies could be used with global temporary tables? I think it could be quite maybe a long question, so I don't know whether you have links to some documents that you have on your website that may be useful.
I think actually I can say very, very quickly, if you can index an ordinary table, you can index a global temporary table in exactly the same way. I think there are limitations in terms of the differences between tables, standard tables and temporary tables. A global temporary table cannot be partitioned, and there are restrictions about foreign key constraints. You cannot do foreign key constraints on global temporary tables. But basically indexing, if you can create an index on an ordinary table, you can create the same type of index on a global temporary table.
Thank you, Jonathan. It's a question for Grant. This is from Carson Jorgensen. Thank you, Carson. Regarding SQL Server and global temporary tables, it seems to me there may be an access control issue. I believe that any login is able to view the contents of the global temporary table. Please let me hear your views on this.
Yes, there is an access control issue. Anyone connected up will be able to reference it if they know it's there. So I mean, it's not like, I mean, I doubt your random business person is going to go in and see, let me find out what global temporary tables are available, right? I mean, they just don't have the knowledge or the wherewithal. But if there is some query that references that stuff, then you're going to see all of the information. Yes. So it is something of an issue. That could also explain why they're not commonly used.
Thanks, Ron. I do have another question for you here. This is from Alfred Rickerfort. Thank you, Alfred. What happens to the temporary table structure in the event of a database crash? Are they recoverable?
No. No, they're not recoverable. They'll go away. I mean, it depends on how, we have to define what we mean by the word crash, but let's just say for whatever reason we restart SQL Server, or you lose your connection completely and utterly, like you were chosen as a deadlock victim, or something along those lines. That temporary table goes away. Table variable certainly goes away as soon as your batch is complete, for good or for ill, and then the regular temporary table goes away as soon as your session is removed, again, for good or for ill. And then the global one, that one actually would stay on its feet, assuming the server was on its feet. But if some database went offline and caused all the connections to that database to go away, then obviously those connections are no longer referencing the global temporary table, so it also would go away. This isn't something I've tested a lot, so I'm not sure of all the variables, but roughly what I've defined is what would happen.
Thank you, Grant. And is this a similar thing for Oracle, Jonathan?
Oh yes. I mean, in Oracle, the global temporary tables are definitely sort of rough scratch pad stuff. They're garbage that you don't have to keep, you don't have to protect, or anything of that sort. So if a session dies, it's GTTs, it's the content of its GTTs are just gone. If the database crashes, every session has gone, the GTTs have gone. Yeah.
Thank you.
It prompted me actually. Sorry, if I'm allowed to ask a question, Grant. When you put data into a global temporary table, are those items that you insert invisibly tagged in some way to say that those are the rows that you inserted? Can you distinguish between your rows and rows that someone else has inserted into that global temporary table?
I don't know. My belief in this case, and so let's make sure I use that word, is no. There's no way at all to know who it was that put that stuff in unless you set up a mechanism yourself to do that. But short of that, no, there's no way. That again, that I'm aware of.
Thanks, guys. We do have quite a few questions. I'm going to try and get through as many as we can. I've got a list of people here who are currently logged in, so I guess I'll just see how many people kind of hang around and engage. We'll try and get through as many questions as we can. So we've got another question for you, Grant, here. This is from Chuck Hamilton. Thank you, Chuck. In SQL Server, is there any performance difference in creating a regular temporary table versus a table variable? Assume no indexes, just a simple create table statement.
None that I've ever recorded. They are basically the same, just for creating the table. No, they're the same. It does change when you start to load the data, right? Because one has statistics, one does not. The one without statistics will load faster than the one with statistics will, because the statistics have to be built and maintained as you change the data. But that's all.
Thank you. Alan McDonald has kind of added to this in a little way. He's asking, are table variables more suited to RBAR procedures and temporary tables for everything else?
To RAR.
So RBAR.
Oh, row by heckanizing row. Yeah. Okay. Here's my takedown on table variables. If you have major recompile issues in your queries, you should look at the possibility of using a table variable. If you are using very small data sets, say less than 100 rows, you definitely can look at table variables as a mechanism. If you are only reading the entire data set after doing a series of inserts, or one or more inserts, and you're just strictly doing a complete read, not filtered, not joined, Again, table variables can be very useful. Other than that, I tend to avoid table variables and use temporary tables in all other cases.
Thank you, Grant. I have a question here for you, Jonathan, from you, Rickton. Thank you, you. Is it possible to have a temporary table as a parameter for a stored procedure or a user-defined function?
As a parameter? Well, I mean, and technically you could pass in the name of a table, whether it's temporary or permanent, to a procedure and then write dynamically created code that uses that table. So I'm not quite sure what the question is trying to achieve, when what the question is thinking of when he asks that question.
So you actually does carry on to say that with SQL Server you have the possibility to use table variables as a parameter for functions and procedures. Is that correct,
right, yeah.
Grant?
Yes, that's correct.
Okay. So is
this question about saying, can I pass the table contents as a parameter to a procedure? Yeah, if it's asking that question, I said you've got this concept of the abstract data type. I'm getting an echo, by the way, of my own voice.
I've been hearing it too.
Yeah, yeah. I guess it's our voices coming back over James's machine. You can create an abstract data type which is of type table, and you can populate a variable of that abstract data type, and you could pass that variable as a parameter to a PL SQL procedure. So in that sense, you can pass a table content, the contents of a table type, a table variable, as a parameter of a procedure. I think perhaps that was the question that was being asked there.
Thank you, Jonathan. So I have another question here for you, Jonathan, from C. Bahadar. Thank you there. In Oracle, performance tuning becomes more challenging with nested views. So if you have a parent view that joins two child views, can you have the child views simply populate temporary tables with the hope of getting better performance? I think this is the type of question that is right with you, Jonathan.
Well, it's a bit too generic for me to be able to give a sensible and correct in many cases type of answer. Nested views are certainly abused. They're used very, very badly, and they're also abused in the sense that people complain that it's the fault of the nested views, when in fact it's not. It's the fault of the way in which the person's used the nested views. I could imagine circumstances where you might actually say something like, and use the common table expression strategy, the with subquery number 1 as select something from view 1, comma, subquery 2, alias 2 as select from view number 2, select from my two common table expressions. And you could then choose to say in Oracle, well, materialize these things before you select. Actually select the data from the view, construct the global temporary tables internally, join two physical tables. And sometimes you will find that that sort of strategy gives you much better performance, because Oracle might say, I can see two views here which are 10 tables each. I will join them together, and then I'll merge the views. I've now got a single query which is 20 tables, and I'm now going to make a complete mess of trying to optimize a 20-table join. But you rewrite it as something which says to Oracle, work out the result from your 10-table join, work out the result from the 10-table join, join two small results together. I did many, many years ago actually have a terrific success with this, because I took two queries which were inline views, which took, I think it was about 3 minutes each, and when you did the join of these views, the query took something like 6 hours to run. But when I turned it into this materialized two results and joined them, the result took 6 minutes to run. Right? So by stopping Oracle from trying to get too clever with the views, yes, materialize them, global temporary table them, you can sometimes find that you magically get a much faster response time.
Thank you, Jonathan.
On SQL Server, just don't use materialized views.
I'm
I'm sorry, nested views.
Nested view, yeah.
Yeah,
I mean, from Oracle's perspective, it's just some text, and it will mess around with the text. Essentially, Oracle will try to take any query you write and turn it into something that looks like a single select list of columns from list of tables.
That's what SQL Server does too, but by nesting the views, you're basically overwhelming the optimizer, and it makes bad choices.
Right. Yeah. Oh, I think we're talking about essentially the same symptom.
Okay.
Essentially, the fact that if you've got too many tables, if you've got 15 or more tables perhaps in a single query block, then the chances of the optimizer picking a bad plan are sort of increase exponentially.
Right. Yeah. Same here.
It's not inherently the views as such. It's the fact that by the time they've all been unraveled and merged, you've just got too many tables in the join, and you just need a tiny bit of luck and a tiny bit of bad luck, and Oracle heads off to infinity.
Right.
Thank you. There's a question here from
James, next.
From Dave Moore. He's asking, is there a SQL Server style global temporary table equivalent Oracle, so that a temporary table it's a temporary table that multiple sessions can access the same data set? I think this is something that you did touch on during the discussion.
Sorry, in Oracle, is there an equivalent? Right. No, there isn't. If you want everyone to be able to see the same data that's being put into a table, it's got to be a standard permanent table. Global temporary tables are extremely private. There are various dirty tricks you can play in order to allow different sessions to see items of data which have been created locally and see them without putting them into a table, but they are pretty much really dirty tricks, and you shouldn't do them in the production system.
Thank you. And Blake Hughes actually has asked a question which kind of follows on quite nicely. So where are global temporary tables in Oracle most useful?
Well, probably in batch jobs where you do something complicated to a lot of data to produce a small result set, a relatively small result set, and then want to run several reports off it. One interesting example of that type of thing, in fact, that a colleague of mine has come up with from time to time, David Kurtz, I think you might have spoken to him, James. David Kurtz is a PeopleSoft specialist in the UK. There are various batch processes, end-of-month type processes in PeopleSoft, where PeopleSoft simply creates what we would call an ordinary table, a permanent table, sticks a load of data into it, reports it a few times, and then drops the table, and then goes through the next cycle of the batch and does exactly the same. And it does this time and time and time and time and time again. And by doing a little cunning manipulation underneath PeopleSoft, David Kurtz has changed the code so that he has a global temporary table created. Its definition goes in once. All these batch processes use it. They get a private table, and because of the reduction in the overheads of throwing the data away after I've finished with this bit, he's managed to reduce batch times on some of these critical batch processes by a factor of sometimes 2 or 3, I think. Maybe better, but I'm fairly sure it was about 2 or 3.
Okay, thank you, Jonathan. We do still have quite a few questions here. What I'm going to do is just ask another question to Jonathan and another question to Grant. This webinar will be posted on All Things Oracle, which has a nice comments function, as most blog sites do. So what I'm going to try and do is put some of the questions that we didn't have time to answer today onto this website. Hopefully Jonathan and Grant can then answer the question there. Particularly some of the questions here are quite long, and I fear they might need a little bit more detail than we'll actually be able to go through. So we have a question here for. So just bear with me. So a question for Jonathan. So this is from Lorden Lotsov. Thank you, Lorden. I hope I pronounced your name correctly. So you mentioned during the discussion that the standard gathering DB DBMS underscore stats is not used for temporary tables. Is it because DBMS underscore stats is an implicit commit? Would you consider using DBMS underscore stats if it does not issue a commit?
Right. Well, you recall I said you've got the on-commit preserve rows and on-commit delete rows option when you create the global temporary table. If you collect stats, as you point out, if you put data into a on-commit delete global temporary table and then call DBMS stats, the first thing DBMS stats does is say commit. So your data vanishes and your stats come back saying there is, quite truthfully, no data in this table. If you populate a table which has been defined with on-commit preserve, DBMS stats will properly gather table stats for you. But of course those table stats are only about the data that you have put into your copy of that global temporary table. And whoever is the last person to gather stats is the person who gets truthful stats. Everyone else uses those stats. So even if you had an option where you could gather stats on a global temporary table, you could not really sensibly use it because only one person gets lucky. Now, having said that, one of the bits about Oracle 12c that got announced at Open World, was it only last week, came up with the point that a session would be allowed to gather private statistics on a global temporary table. So 12c, when it comes out, will actually allow us to deal with the problem of we all share the definition, but we use different amounts of data. You can have private stats, and it's a call to DBMS stats, I think. Oh, and yes, another feature that got mentioned as well was Oracle, in this case, catching up with SQL Server. When you load data into a table, Oracle will automatically, if it's the correct type of load, not ordinary inserts, but direct path loads, create a select, there are cases where Oracle will collect stats on the object as you load the data. That's it from me.
Great, thank you, Jonathan. So for Grant, we've got a question here from Dawn Rigby. Thank you, Dawn. Dawn's seen examples of SQL Server using hash temp tables to break up the processing of a SQL statement, where in Oracle I just use a single select statement. When I've queried why it was done in that way, I've been told it's to reduce contention to other queries or because SQL Server processes are quicker that way. Is this a typical abuse of temporary tables in SQL Server? I.e., do people overuse them, whereas perhaps they would be better off writing a more complex query and allowing the optimizer to decide how best to process the query in one go?
Wow. That's one of the toughest things to answer. Let's just say it's situational. Yes, this is an area where people absolutely abuse SQL Server. They definitely will break down statements way more than they need to, and use temporary tables as a mechanism for putting stuff back together. I've seen that a lot. It's definitely an anti-pattern. However, it's also very useful when you identify an area where the queries are overly complex as a single statement. It's a way to break things down into smaller chunks in order to do the processing in a more focused fashion. And because you can take advantage of statistics to put everything back together, or a query, or a join or whatever, it actually is functionally an extremely useful tool to have in the toolbox. But I think it becomes a hammer, and there's an old saying, a hammer will fix or replace anything. Same thing goes with temporary tables for some people. They will, anytime they hit a performance issue, they will immediately start plugging temporary tables in, and I don't think that's a very good pattern at all. But the short answer is it depends.
Is it possible to a certain extent that this is a sort of historical thing, that it was perhaps a little more necessary 10 years ago, but people haven't gradually moved on to the fact that the optimizer is better, the equivalent sort of things that I would call read consistency, the reduction in potential read locking and side effects and so forth is less pronounced and so forth?
Yeah, I mean, SQL Server 6.5 and SQL Server 7.0, which I'm wonderfully old enough to have used extensively, absolutely needed this type of processing. But that's more than 12 years ago now, when those came out, when those are in use. Since 2000, it's much more situational that that's the correct mechanism. Boy, Jeff Moden does a fantastic presentation on how he uses a tally table, a table of numbers, to pivot data, but he breaks it when he gets into the 10 millions, hundreds of millions of rows. He does break it down into temp tables as a mechanism to speed up the process, because while he can write the query as a single statement, it's just simply processing too much data. So it really is one of those things where I don't want to say you should never do it, but I would say that you need to be judicious about its use.
Yeah.
Thank you to Jonathan and Grant for taking this discussion. Thank you to everybody, obviously, for joining as well.
Yes,
it's been a pleasure. It's been most enjoyable. Thanks very much, James, and thanks very much, Grant.
Oh, no, thank you, Jonathan. Absolutely.
Thank you.